Thales theorem, that's the topic of this video. Thales theorem is also called basic proportionality theorem. Now, let's consider a triangle A, B, and C. Now, I'm going to draw a line perpendicular to BC over here. So this line, I'm going to call it as DE. And this line, DE, is parallel to BC. So our DE is parallel to BC. Great. Now let's start to mark this length here. This length will be AD. Okay. So I'm marking this with a L line, and I'm marking the length DB with a blue line. So I can call this ratio, which is AD over DB. Okay, so this is the ratio AB over DB. Similarly, let's mark this length here with a L line and this with a blue line. So AE and EC. So let's put this ratio AE by EC. AE here and EC. Okay. So now we have divided the triangle by a straight line, and this line is parallel to one side of the triangle, and we have marked their ratios on both sides. Now the Thales theorem says this ratio will be equal to this ratio. It's as simple as that. That's the theorem. The theorem is, if you have this line that divides the triangle, which is parallel to one side, then it automatically divides the other sides in the same ratio. All right. So now let's go and see how we can prove this. Here we'll look into the statement of the theorem. So the statement says a straight line drawn parallel to a side of triangle intersecting the other two sides divides the side in the same ratio. So that's the statement. So what does that mean? It means that the line DE divides the two sides by the same ratio, and also DE is parallel to BC. Okay, now, so for the proof, what is given to us is, in triangle ABC, you're given this triangle ABC. D is a point on AB. This D is a point on AB. And E is a point on AC. So E is a point on AC. Great. We have to prove that AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. So that's what we have to prove. So let's draw a triangle here, and let me start marking these points. I'm going to replicate that triangle here, A, B, and C. Great. Next, let's draw a line DE. Okay, so that's a line DE. So this is point D, and this is a point E. Next, we can see that angle ABC, which is ABC is this angle here, is equal to angle ADE, to this angle ADE, which is this angle. So we're going to call this as angle 1. So let's write it down. This is angle 1, and this is angle 1. And they're corresponding because they are the angles or the corresponding angles of a straight line which is passing through two parallel lines. So similarly, we can show that ACB is equal to angle AED, and we can mark them here as angle 2. Using the same concept, they are the corresponding angles of a straight line passing through two parallel lines. Great. Next, we can see that the angle DAE is equal to the angle BAC, which means angle A is common for both. So let's call this as angle 3. So you can see clearly that the three angles, angle 1, angle 2, and angle 3, are the same for the two triangles ADE and the triangle ABC. Great. Now let's mark this triangle ADE here. So I'm going to call this triangle as ADE, which has this angle 1 here, angle 2 here, and angle 3 here. Right. Now let's look into the further proof. So we can say that the triangle ABC, our big triangle, is similar to triangle ADE. ADE is nothing but this triangle here. I brought it out just for you to visualize. So these two triangles ABC and ADE, which I have brought it out here, are similar triangles by the AAA method, which is all the three angles are equal. Now we can say because they're similar, the proportion of their sides is equal, which is AB is the length of the side here of triangle ABC divided by AD is equal to AC divided by AE, right? So we have that here. AB divided by AD is equal to AC divided by AE because they are similar triangles. Next, our AB can be written as, this AB can be written as AD plus DB, and our AC here, which is this AC here, can be written as AE plus EC. So let's do that. So if we do that, then let's bring AD separately to the numerator. So you will get AD by AD plus DB by AD, and AD by AD will become 1. Similarly here, by expanding our AC as AE plus EC, and when you take the denominator separately for each numerator, this AE by AE will become 1. Alright, so this is 1 plus DB equals to 1 plus EC. So it's 1 plus DB by AD is equal to 1 plus EC by AE, right? So further, we can remove this 2 1 and we have AD by DB by AD is equal to EC by AE. Now let's take the reciprocal of it. Okay, so the reciprocal, you will get the AD will go up and DB will come down. So AD by DB is equal to AE by EC. So you can see that's our required proof for the theorem. So it was a very simple way to solve or to prove the theorem. Next, let's see a corollary to the theorem. If in triangle ABC, you have this triangle ABC, a straight line DE parallel to BC intersects AB at D and AC at E, then we have to prove that AB by AD, which is AB by AD, is equal to AC by AE, which is AC by AE, which is 1. And the second, we have to prove that AB by DB is equal to AC by EC. That's very simple. So let's move on to solving this. So for the proof, we know that our DE is parallel to BC, which is given to us. Okay, so in triangle ABC, DE is parallel to BC. So we know, we just proved the Thales theorem, which is called the basic proportionality theorem, and it states that If DE is parallel to BC, then AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. Next, let's take the reciprocal of this for the first case. So when we take the reciprocal, it becomes DB by AD is equal to EC by AE. Okay. Next, let's add 1 to both sides of the equation. So adding 1 here and adding 1 here. Now, if you further simplify and take AD as your denominator, then this will be DB plus AD and this will be EC plus AE, right? So you have DB plus AD divided by AD, making AD the common denominator, and this also here. Simplifying this, you get this. Now, DB plus AD, DB plus AD is our AB, right? So we can replace DB plus AD as AB, and our EC plus AE, which is EC plus AE as AC. So this becomes AB by AD is equal to AC by AE, right? AB by AD is equal to AC by AE. So that's the first part of our theorem. So to prove the second part of a theorem, we again use the Thales theorem, but this time let's add +1 and +1 both sides of the equation. So adding plus and +1 here, and taking DB as the denominator, common denominator on the left hand side, and EC as the common denominator for the right hand side, you get AD plus DB, which will be AD plus DB, and that will be AB on the numerator here, and the other side AE plus EC, AE plus EC, and that will be AC. So then again, you have proved the second part of the corollary. Next, let's use an illustration to explain Thales' theorem. So here it says, draw an angle XAY. Okay, so let's call this as X, A, and Y angle. And mark points B1, B2, B3, B4, and B such that, and this should be marked on the ray AX. So on this ray AX, let's mark B1, B2, B3, B4, and B such that AB1, A to B1 is equal to B1, B2, B1, B2, and B1, B2 is equal to B2, B3, equal to B2, B3, B4, and it's equal to B4, B. So let's mark them. So this is our B1, B2, B3, B4, and that is B. Okay. So we know that they are all in equidistance. So AB1 is equal to B1, B2 is equal to B2, B3 is equal to B3, B4 is equal to B4, B. All right. So that's given to us. And let's assume that they are 1 centimeter. All right. Now, what we will do is similarly on the ray AY, which is this ray AY, we're going to mark the points C1, C2, C3, C4, and C. Okay, C1, C2, C3, C4, and C such that they are all equidistant. Okay, AC1 will be equal to C1, C2, so on. Let's mark them. C1, C2, C3, C4, and C. So we can say that they are equidistant. Now let's join B1, C1, and B and C. Right. So once we have done this, now we can say that the ratio AB1 divided by B1, B. So this length here, which is AB1 divided by this length B1 to B. B1 to B will be 1, 2, 3, 4 parts, yeah? And this is 1. And we have assumed anyway this to be 1 centimeter. So 1, divided by 1, 2, 3, 4. So this will be equal to A B1 by B1B. A B1 by B1B is equal to 1 by 4. Similarly, since they are all equidistant on the right hand side on the ray AY, you will get AC1 divided by C1C. So this is 4 times this length, right? C1C is 4 times the length of AC1. So AC1 over C1C can be written as 1 over 4. So we have that. And further, you can also observe that our B1C1 is now parallel to BC. Okay, so similarly, let's now join our B2C2, B3C3, B4 and C4, right? And now you will see that this ratio, which is AB2 over B2B, AB2 will be 2 and B2 to B will be 1, 2, 3. So it will be 2 over 3. So we can say that our AB2 by B2B is 2 over 3, and also we can similarly say that AC2 by C2C will be also 2 over 3. And you will also notice that our line B2C2 is parallel to BC. Similarly, we can prove that AB3 B3B is 3 by 2. That is equal to AC3 by C3C, which is also 3 by 2. Similarly, we can show that AB4 by B4B will be 4 by 1, and that's equal to AC4 by C4C, that's also 4 by 1. So you can see that. And all these cases, you will find that B3C3 is parallel to BC, B4C4 is parallel to BC. So hence, we can see that the ratios by which they are divided is equal. And from this, we observe that if a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.